I'm going to explain how to draw transformations of trig functions in a method I call BHAPPI. B-H-A-P-P-I. Sorry for the misspelling. For the sake of this tutorial, I'm going to explain first what do these letters mean. B represents the basic function, which in this case, and in this sinusoidal function, it will be the sine function. If it was a cosine function, the basic function will be a cosine. And if this was a negative 5 sine function, let's say, then the basic function would be negative sine x, let's say. H represents the vertical translation. Again, we have to write it as H, as height. A represents the amplitude, which is the absolute value of the value here, whatever is used as A. Mostly it's written as A in generic sinusoidal functions. P is the period of the function, and another P is the phase shift, and the I is the intervals that we'll have to draw. So the first thing we need to do is draw a table with 4 columns and 2 rows, as you see in front of you. And since here our basic function is a sine function, then we will simply draw here that sine graph. So we just slide it in. Make sure that it's in quadrant 1. So we're taking the sinusoidal function in quadrant 1. So this will be here 0, and here it will be 2 pi. Now we will look, that's the basic function. We'll look at the height, and the height represents the axis of the curve, or the vertical translation. And in the first function, the vertical translation is a +10. So instead of the axis of the curve being at 0 here, we will have to translate it to 10. Then we look at the amplitude, and the amplitude is absolute value of +5, which is 5. Therefore the value up here will become 15, and the value down here, since it's a 5, so the difference between the axis of the curve and the max or the min must be 5. So there you go, you have 15 minus 10 is 5, that's the amplitude here, and 10 minus 5 is 5, and that's the amplitude here. Then we look at the period. We know that the period is 2 pi divided by the letter K. And K is the letter that represents the horizontal compression or stretch factor, which is located in here. Follow the cursor, please. And in this case, when we looked at the first function given, the K value was not factored, and as a result we had to factor it before we could use it, because that will definitely leave an impact on the phase shift. In here, many students get tricked into thinking that the phase shift is 3 units to the right, whereas here it's obviously 1 unit to the right. So after using the period, realizing that it's 2 pi over K, and K is the number 3, so the period is 2 pi over 3. That means that this has to change from being 0 to 2 pi into 2 pi over 3. So my whole period goes from 0 to 2 pi over 3. And then we have to realize what is the phase shift. The phase shift is the number 1. And since it's x minus 1, that means, and it follows, that follows the general equation for a sinusoidal function, which I will write in here. Y equals a sine k bracket x minus d plus c. Oops. So as you see, the two equations, I've tried to align them up so you could realize the letter D in the general equation must be the same as that number 1. So D is equal to the value 1. Had this sign here been plus, then in order to make it resemble the general equation, this plus sign would have to be minus multiplied by -1. And therefore D is equal to -1. But in this case it is 1. So we have to shift the function by 1 unit to the right, and that 0 here will become, I will write that under it, that 0 will become +1, and the value 2 pi over 3 will become 2 pi over 3 plus 1. Then we need to look at the intervals in order to know where does the maximum, the axis of the curve intersection again, and the minimum lie. So if you notice, how many intervals do we have in here? We have 4 intervals, and we take 2 pi over 3 plus 1 minus 1, divide that by 4, or we take simply the period, which is 2 pi over 3, and divide that by 4, and we will get 2 pi over 12, and that will be the value we will add to 1. So 1 plus 2 pi over 12, and then the answer we add to it 2 pi over 12, 2 pi over 12, etc., until we reach eventually 2 pi over 3 plus 1. So the intervals that will be here will be 1 plus 2 pi over 12, and remember the 2 pi over 12 was the result of the division of the whole period by 4 intervals. So we're realizing instead of having 2 pi divided by 4, which is pi by 2, and that's how every quadrant is formed, we are taking 2 pi over 3 and dividing that by 4, and we get 2 pi over 12, which we could simplify that to pi by 6. So we're adding pi by 6 as an interval. So here we started with 1 plus pi by 6. We get 1 plus pi by 6. We could change that to a decimal, of course. Then we're adding to the 1 plus pi by 6, we're adding a pi by 6. And as we know, pi by 6 and pi by 6 is a pi by 3. So this here we could write it as 1 plus pi by 3. And to the 1 plus pi by 3 we add another pi by 6, and if you remember, pi by 3 plus pi by 6, that's like 60 degrees plus 30 degrees, which is 90 degrees, and that makes a pi by 2. So 1 plus pi by 2. And if we take that value and we add pi by 6 to it, we will get 2 pi over 3 plus 1.